Hey everybody, Lars here again. Um, Playing around with time here. Didn't release it Friday night, but I did shoot this video Friday night. I shot your first review video earlier, and then I just watched the basketball game. So Golden State won, game 4, pretty big. So they are up 3 games to 1, and it's over. Cleveland's not going to win 3 in a row and come back, especially with 2 of the 3 remaining games in Golden State at Oakland. So Golden State's going to be the NBA championship champion again 2 years in a row, which is pretty interesting and pretty cool. But forget that. What we are going to do here in this session is this is going to be the third video. Even though I'm shooting it second, this is going to be the third video you're going to get because it builds upon some of the things we did in the second half of Unit 2 as far as using loops and doing iteration and doing stuff like that. But this is a fun video for me because I always begin it by telling the story of my computer science kids and the Just Euler problem solving club. Back in the day, when I was first working in the cave, we had first built the cave and it was becoming popular. Kids would come in to the lab and they would ask me and my iLab assistants what to do if they wanted to learn Python. We didn't have any Python classes. You guys are very lucky. Now you have a Python class to take. And at the time, we told them, and I queued some stuff up, to go to learn Python the hard way. And we told them to run through all of the, how many ever 50 chapters there are, in Learn Python the Hard Way. We described the differences between 2.7 and 3 point star, like I did in the first class for you guys. And we went through all of that stuff. Then we would tell people after they went through Learn Python the Hard Way, we would send them here, projecteuler.net. It is pronounced Euler. I always tell the story. When I was younger, I always said Euler, and I had to be corrected in front of a classroom full of math students by a math professor once when I was in college. It was very embarrassing. So to this day, I still do it. So don't be surprised if I do it in this video, actually. But it's pronounced Euler. The site's named after the famous mathematician. And basically what it is it is a list of 500, getting close to 600 number theory problems, things that lend themselves to being solved with computer science. If we real quick go over here to the archives, we can look at all of the problems. And if you click on them, it describes the problems. But we're actually going to log in because I did something for us. I'm going to go to sign in. And I'm not going to log in with just that S. I'm going to say SU. So username PMDS -SU, lowercase u, 2016. The password is Python12. So you guys can go log in if you desire. 4839, just so I can prove I'm not a bot. And I'm going to sign in. Hey, look at that. Sign in successful. So we're logged in with a user ID that I set up for the class. And we can see now the problem archives. Okay, but now that I'm logged in as this group, now I can chart my progress. So if I go here to progress, I can see that I have not solved any of the 563 problems that we have. But we're going to change that today. We're going to take a look at one of the problems and solve it using some of our new tools. Anyway, back to the story. We would tell the kids to go to learn Python the hard way. And once they've done all of the work there, take their Python skills and go to Project Euler. And if they went to Project Euler and did about, I think we said the first 50 programs, because if you look at the problem statistics, and the Euler site is great. Once you start answering problems, it'll tell you what everybody else is doing. You can come here to the stats and see that if you solve the first 50 problems, it puts you in the top 6% of people who use Project Euler. So we thought that was pretty good. We wanted to get to 5%. I think we used to tell our kids, where's the 5% mark? We used to tell our kids to do 57. So that would get you, that would become what the club called being a 5%er. So that's what we would do. We would have kids learn Python the hard way and then go to Project Euler. So usually when I run my Python class, I want to make sure I tell you guys, my students, about Project Euler and what we used to do and how we did it. All right? But enough of that. Let's go to the archives and let's go take a look at Euler problem number 6 here we go. I'm going to read it out to you. The sum of the squares of the first 10 natural numbers is, and then it shows this sequence, and the answer is 385. The square of the sum of the first 10 natural numbers is, and it shows you the math, and the answer 3025. Hence, the difference between the sum of squares of the first 10 natural numbers and the square of the sum is 2640. Okay, so we have a worked solution for the first 10 natural numbers. Then what Project Euler tells us is find the difference between the sum of the squares and the square of the sum for the first 100 natural numbers. Okay, something like this lends itself to being solved algorithmically with computer programming pretty well. And, you know, knowing what we know about Python, this is not going to be hard for us because we could solve the problem for 10 and then just go in and alter our loops and change them so that instead of 10, they go up to 100. And if we follow the same algorithm, it should work and give us the solution. So let's give that a shot. Let me put that down. And I already created a program for us to use. I called it Euler6.py. And as you know, when we're done, I'm going to put it up in the Sakai. So you'll be able to see it and you'll be able to look at it. So what is the first thing we want to do? I used to do it in the other classes. Should I do it? Yeah. What I used to do is I would just highlight the entire problem and put it in as a comment. So why not? Let's highlight that. Let's come back here. 1, 2, 3. And then paste. And as you can see, that doesn't look very good. But what you do is this. And there you go. That makes things a little bit better. And look at that. Right there in our program itself in line, we have the description of the entire problem. So that's a pretty good deal. So the sum of the squares of the first 10 natural numbers is blah, 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 blah. So how do we find the sum of the squares? Let's do a variable called sum of square and make it equal to 0. And then let's use our new tool, the loop, and say for I in range 0, comma, well, no, I want to do 1 because I'm starting with numbers. And then I want to go to 11 because 11 is what? The first thing we don't want. And what am I going to do? I'm going to take that sum of square. I'm going to make it equal to sum of square because it is an accumulator. You know, we went through that in video number 2 with the counters and accumulators. So this is an accumulator, but we want it to be equal to this plus what? I, but we just don't want to add I because we want the sum of the squares. So what do we want to do? We want to square it. Okay? And then when we hop out, we'll print our stuff along the way. The sum of the squares is, yeah, that was good enough, comma, and then we'll do some, all right, let's test ourselves along the way to make sure we're good. And 385 is absolutely correct because they tell us what the answer is right here in the thing. So the sum of squares is 385. We are good. We have done the first of 3 things we have to do. Now, what is the second thing we have to do? The square of the sum of the next of the sequence is what we want to get next. So let's call it square of sum equals 0. And then we'll do for I in range 1, comma 11. 11 is the first thing we don't want. Now I want square of sum to be equal to square of sum plus what? Well, this time we do want I because we want to accumulate everything in that range first. And then when we bounce out, we want square of sum to equal square of sum squared. And then we will have now, just do it from scratch, print the square of the sum is all right, let's see what we get. All right, and that's correct too because as we can see from right here, 3025. So what is the third thing we have to do? Quite simply, all we have to do is and we're going to do it right in the print line. The difference is, I'm not going to describe things, and I'm going to say square of sum minus sum of square. All right, fingers crossed. Look at that. So we have the sum of the square is 385. The square of the sum is 3025, and the difference is 2640. And if we come back here to our description, we'll see that that's absolutely correct. Okay? But we're not there yet. And why aren't we there? Because Euler's not asking us for this. They didn't ask us to just code up what they wrote. They want it for the first 100 natural numbers. And that's easy for us now. Why is that? Because we're programmers, and we know all we have to do is make 2 changes to what we have already. And it's very simple. Take that 11, make it 101. Take that 11, make it 101. Now, instead of 1 through 10, it's going to be 1 through 100. And that's what they want. The first 100 natural numbers. Okay? I'm going to save. I'm going to run. And we get this completely different rack of numbers here. So the difference is this number. We're going to go back to Euler, and we're going to test that in a second. But the first, as I look at this code, there's one thing that I want to do. Usually, when you have a program and you have a variable that you want to change in a bunch of places, it behooves you to create a variable. I'm going to call this one limit. And at first, I'll say 10. And we can use a variable in our ranges. So I'm going to say limit here. And I'm going to say limit here. Okay? But we have a problem. And what's that problem? Okay? The problem is this. I say 10 because it says up here the first 10 natural numbers, and it just seems natural to call it 10. But in my range, I want the first thing that I don't want. So instead of putting 11 up here and doing it that way, okay, which is one solution to this issue, I like to keep the variables natural. Remember, this is Python. Readability is important. So if my range is the first 10 numbers, well, maybe my variable should do that. And I can very easily just do this. Watch. +1. Easy. So I can say limit +1, and all of a sudden I'm fine. Because then I take account for the fact that I want to use the first thing I don't want as an exclusive end of range. Okay? And now I have the variable in one spot. So I rerun, and I see we are now back to getting what we had for 10. But now, instead of 2 spots, I just change it in 1 spot. And now I've done it for 100. And now it's easy. I mean, and you guys know, I mean, you have the experience now. You're becoming programmers. You can put an input statement in there and just have the user enter it, and boom, you could get it for any number that you wanted now. Okay? So, what's left to do? What's left to do is go see if we're right. So I'm going to take this number right here, and I'm going to copy it to my clipboard, and we are going to venture back to Euler. You put the answer here in the answer column, okay? Column, the spot. And then you have to put in the number here because we need the CAPTCHA stuff so they know we're not a bot. All right? And then I'm going to click check. And if we were correct, we're going to get a check mark. A little guy's going to show up with a big green check mark next to it. And it's always a good buzz when you get that. No matter how many of these you solve, when you get that check mark, you're like, yeah, it's a good deal. All right, here we go. You ready? All right, wait for it. Don't be nervous. Check. Woohoo! And look at that. We got our big check mark, okay? And a lot of people have solved this problem. But we did it. We got the correct answer. The correct answer was right here, 251-64150. And we punched it in, and we put that there. So now, when we go to progress, we have solved 1. And look, it's right there. It's marked off for us. And anytime we want, we can go click on it. And it'll tell us when we solved it. And it'll show us the answer, which is pretty cool. Now, I gave you the ID and I gave you the password. If you want to go bang some out and do it here for practice or for fun, go ahead. But what I would do if I were you is just go to Project Euler and create your own ID for yourself. And if I logged in as me, I've solved like 150 of them. So I'd have like, stats out the wazoo. But you want to start building your own and solving your own problems. And that's the way you want to do it. That's why I always start these things fresh, because you want to build on these things, okay? My kids at Rutgers, the Just Euler Club, they have their own accounts. And they have one joint account, but they also have separate accounts that they use to solve the problems and do things like that. So for the past year and a half, I guess it's been, the kids, 2 years ago, I did a seminar called Just Euler, and the kids liked it so much they decided they were going to make a club out of it. So they made the university club, and it used to be Euler problems and some other like psychology of problem solving stuff, but it has actually morphed into interview practice. The kids got a book called Cracking the Code, and when they do problem solving, they do it in a way where it's helpful to them to practice for interviews when they go get jobs afterwards. So it's actually pretty productive. They also have their classmates who have gone out to the real world and got jobs to come back and sit and talk to them about the interview process and what they do, and when they have live coding in interviews, and what they should concentrate on and what they don't have to sweat too much. And they've really done a great job with it. It's really, one of the things in the department that we're most proud of is that, all we can do, we could provide resources and ideas and all of this stuff, but the kids have to come through and see it to fruition, and a bunch of our kids really have recently. So I think it's a great thing to do, because if you're a computer programmer, problems are like food, okay? You need different problems. Oh, I can attack it this way. I can do it this way. I can work on this. And when you learn Python, you are putting things in a toolbox. But with that toolbox, toolbox is great to have, but you got to build something. You got to have a project, okay? Sometimes when you're learning, you're like, why am I doing all of this? When am I going to be able to use it? Well, Project Euler is where you can go and use it. Go practice at Project Euler. If you've gone through the slides and the resources and all of that stuff, and you've done your assignments and you think you're done, but you want to try some other things or you want to do some more, Project Euler is perfect. Go there and practice, okay? Now, as a caveat, there are tons of places online that if you just Google Euler, whatever, that the answers are all out there. And truth be told, all honesty, you're not really supposed to advertise the answer to Euler problems. Like what I've done here to create a video and put it on YouTube that solves Euler 6 is not really a good thing to do. But I don't do any others except 6. So like I've said it before, I've ruined this one for the planet. But I don't do any of the other ones. And this one's pretty easy if you think about it. It's a contrived math problem. So I don't think I'm stealing, the way for, if somebody really wants to solve it and not know the answer, they're not going to go looking around YouTube and Stack Overflow to try and get the answers anyway. So I'm not really worried about that. But I'm sure lives aren't being ruined because I gave people the answer on this one. It's not a big deal. All right. So now you know what the deal is with Euler. You could go create an account and solve some of these problems for yourself and use your Python. Python is a very popular language for the Project Euler stuff. Some people use, different math products like Maple and Mathematica and stuff like that, or Wolfram. Other people use Java. A few people out there will put up C++ solutions, but a majority of the solutions, a lot of them are Python, because Python's perfect for something like this. Just little quick demos, really quick, proof of concept things. It's perfect for mock-up purposes, Python, because you could just really quick just whip something up. Okay? All right, so you've got Project Euler. You've got that under your belt. You're in pretty good shape now. I'm going to use my brain and realize that I'm not giving you this video till Sunday or Monday. So by then, you should have your slides. You know your Zell readings. You will have at least your first assignment, if not your second one, in the next couple days. You've now gotten 2 review videos and this video. So you've seen, loops in action, doing some problem solving and things along those lines. That should be the majority of the resources you need to do your homework assignments. You got CalPy, and you've got the other problem, and you should be in good shape now as far as resources is concerned. You've also, over the weekend, I put up the information sheet for the midterm project. So you got a month to do it, because July 13th is the due date on that. But I want you to at least know about it now, so that you can schedule your time properly. So if you have a lot of time now, you could do it now, or if you have to backload it and do it in a couple weeks, you can do that. At least now you know what's expected of you so you can plan ahead, all right? All right, good. I am getting out of here. I think I am not going to do review video 2 until tomorrow because 2 videos in one day is quite enough. I think I'm going to go watch season 2 of Bloodline on Netflix and slurp coffee and relax. Because when I first got back from New Orleans, the first thing I did was, a buddy came and got me at the train station. He brought me home. The first thing I did was took a shower and I went to sleep. So I woke up, had a little dinner, and I said, you know what? I better get some Python done because I've been walking around New Orleans for 2 days, 3 days. I better get back to work and get going here. So I did. Now I feel better about myself. Now I can sleep well tonight, knowing that 2 videos are in the bag, 1 more to go, and you're going to have all your Unit 2 resources, and you guys are going to be happy campers and productive programmers. And at the end of the day, that's what we want, right? All right, you be good, and have a good night, and I will talk to you very, very soon, all right? Be good. Bye.